Hi everyone. In this video, we'll talk about how we can calculate area of gain and loss in a certain country, a study area called Gabon in this case. So I'll use country's boundary and then subset Gabon study area, a relatively small country, and then so we'll calculate the total gain and loss forest cover in a certain year, and we'll be creating a function that calculates the loss as well as the gain, and then we'll summarize our data. Let's get started. So first thing is to import actually the country's boundary to help me subset a study area, in this case Gabon. So I'll create a variable called countries, and I'll filter the first I need to actually import the fusion table and EE feature collection. That will import the feature collection ID. In this case, I have to provide that, and I already know this beforehand. So US does LSIB simple /2017, and the other thing is it's giving me some errors, so I have to fix this. Okay, so this has to be equal. Okay. And the next thing is, so what it does is this will import the country's boundaries, and this contains administrative boundary for all countries around the world. In this case, I need to select for one country, Gabon here. So I'll be subsetting for Gabon. And to do that, I need to filter this data. Let me create a variable Gabon for that country shapefile, and call this country's feature collection data. I'll copy paste actually that, and once I do that, I'll filter it by country name. So filter, and then I'll cast the Earth Engine filter function. That's a built-in function. Equal filter equal. I need to provide the parameter or the field that I need to use, and also the specific field ID that I'm interested. So in this case, what we do is provide the specific field or property that we want to use for filtering. Okay, so it's country NA. That means country name in a short way. That's if you open this database, actually you'll see this field in a GIS environment. If you open this data, you'll see this field. So using country name, which country am I interested? So I need to provide that. So Gabon, based on country name, we will select that country, Gabon, and that our function is pretty good to go now. The next step is to actually import the Hansen, the global forest change data, the Hansen forest data. Okay, so tree cover 2014, that will be our variable, and we need to import that. It's an image, so we need to cast Earth Engine image that will import the image. Then next is to provide the image data, the Hansen forest cover data, and I need to provide that. It's I think UMD, that means University of Maryland, and Hansen global forest change 2014. And so this data contains it's a global data, and contains forest loss and forest gain. Okay, so based on that, I will select the two layers. I need to select the forest loss and I need to select the forest gain. That means the total, the total amount of area, or just any pixel that's classified as lost compared to the baseline 2001. So let me create a variable called loss, and that's a variable. You can name it differently if you want to, it doesn't matter. And then from the tree cover data, this one we have already imported, right? I will select the band that I'm interested in. This case, I'm interested in loss layer. Okay, so that will import only the loss layer from this the global forest data, or the Hansen data. So the next step is to, in the same way, we need to import, or select rather, the gain data. We'll use the same tree cover. Oh, there's a typo here. Let's just fix that. So tree cover 2014, and then I'll select, again in this case, instead of loss, I'll say gain. So this will select the gain data. Okay, I'll close my statement. The next step is, so what we have imported here, the countries database, and we have imported the Hansen forest data, and we also selected the loss and gain data. And the next step is to actually write a function that does calculate area, total area. So in this example, what we're interested in is to calculate the total amount of pixels or area in Gabon that have been classified as loss, and also that have been classified as gain. So that's our purpose. So let's write that function. That's that magic function that creates or calculates the total area. So that is area loss. So we not need to calculate the area loss. That's a variable that I created, and we need to use this data. If you're calculating the loss, we need to use that data, the loss data, forest loss data, and then multiply by image pixel area. Perfect. So this will calculate. So we have pixels here, right? So we know the total number of pixels in this within Gabon, right? Forest pixels classified as loss. That means there is forest cover change, or there's a loss, right? And then to calculate total area, what we need to do is we multiply it by image pixel area. This will give us a total pixel area in that study area, in this case Gabon. Okay, we'll do the same thing actually for the gain data, right? So for gain data, we use the same thing, area gain. So area gain, and then instead of the loss here, we need to input the gain data. Okay, so the gain data, I can copy that and paste it here. And the same function, multiply image pixel area. Again, this will calculate the total area using this raster data, using this gain data, the gain layer. This gain multiply image area image pixel area will generate the total number, the total amount of the total area that is classified as gain. Okay, so now we have two functions here. Using the raster data here, this function area loss will calculate the total number of pixels, the total pixel area within Gabon that's classified as loss. However, this one on the other side will in contrast will calculate the total amount of pixel area within Gabon that's classified as gain. Okay. In other words, we can say that deforestation, total area of deforestation for the first one, and then total area of afforestation or more greening or planting of trees, right? So let's we're not yet there. Just we have written the function. We haven't applied that function to our data. So and so what this does is it will use the entire data, right? If it's a global data, then it will use this function for the global data. But what we need is total area for Gabon. So we need to specify study region to make this function complete, okay? So the next step is to actually calculate, we'll use this title actually, calculate area of loss pixels in Gabon, okay? Then to first let's create that function here. So loss stats, I'll calculate the loss stats here, right? So I'll give it area loss. So this is our function that for every pixel it calculates the total area of loss. So we need to call that area loss here, and then that's the fun part. Reduce region. So reduce region will use that raster data and that area calculation function and then subset it to a study area. That's the beauty of reduce region, okay? So by using reduce region, we can actually provide the Gabon study area here, okay? That will create our function for that specific area. Okay, then this will need a parameter called reducer. This will need as an input a reducer. So in this case, our reducer is we want total pixels, total area of pixels. So we need to use sum. Okay, so reducer or Earth Engine reducer and sum. So this will actually calculate the total pixel area. Okay. So if you want to use Azure Statistics, we need to define it. But in this situation, we need to use reducer sum. So that will calculate the total pixel. For every pixel, it will sum up the total area. Okay. And then this one will provide total area for every pixel. So this will assign for the entire raster data. It will assign total area for every pixel. Now what we're doing here is kind of summarizing that over our study area, in this case Gabon, right? Okay, let's complete this part of the script. And then the next one is geometry. It needs a geometry. As I mentioned, we need a study region, a subset here. So we need to input a geometry, okay? And then Gabon. So Gabon is our geometry. So this is not yet a geometry. So we need to add geometry features so that we can use that geometry for our analysis. Okay, geometry. All right. And then the last bit is when we're summarizing this, we need a spatial resolution. So in this case, because the Hansen data is a byproduct of a Landsat. So Hansen et al., when they published this paper, they used the Landsat data, the global Landsat data, and then Landsat data is a 30-meter spatial resolution, right? So the Hansen data is a 30-meter spatial resolution. So that way we understand that the spatial resolution of the Hansen data. So we need to define scale or spatial resolution, in other words. So based on that, our scale is 30. That's why we need to define 30. And the next thing is to complete this function is, because this uses, Landsat label 30-meter data, it's a huge, large data. So if we don't define a max pixel, it will crash or just we'll hit our limit. So max pixels is a pretty useful parameter. So I'll define as 1E11. This will make it safe to run for this analysis. Okay, excellent. So this will create a function that calculates a total area, total pixel area that's classified as loss in the Hansen data. Okay, so the next step is actually how do we visualize that? Okay, so let's do one more thing. So print, okay, area lost in Gabon. Okay, that's what we wanted in this exercise. Okay, so we need to input this. So this is our stat. We already calculated the area, right? But we need to visualize that. That's what we're doing here. So get loss, and I think we need just to close this. Square meters. So that's what we need to do here. So, okay, so our first thing is to actually, execute this code, okay? So when we execute this code, we need to see something here, like the total area of, pixel classified as loss in Gabon. Let's execute that. Excellent. So Earth Engine is running behind the scene. So mind you that when you run Earth Engine, there are, tens of thousands of computers on Google's data center that we're using here to analyze that, and then thanks to Google providing this resource, huge resource for research and what have you, research purpose. So now, so area lost in Gabon, and then this is our total area in square meter. Okay, this is in square meter, total area of forest classified as loss. So this is the total area of deforestation in that year 2014. Okay, so that's fantastic. So our function is working. Now we have one more step. Okay, so we've calculated the total area of gain. Now we need to calculate the we calculated the total area of loss here. Now we need to calculate the total area of gain. And actually, to save time, I can copy this and adapt, okay, just to save time, since most part of this script is similar. So instead of loss here, we have gain, right? So gain stat here, and then area, instead of area loss, we have area gain. Okay, and then everything else should be the same, right? So we're applying the same function, but we're just changing it into a different raster area, and not only raster, actually the gain function that does the so this one here. So the area gain function that will calculate for every pixel total area, total area for every pixel of gain, of forest gain. And then we need to do the same thing here. We just calculated the total area of loss, and then we need to calculate the total area of gain. And then we need to adjust some, small adjustments here. So instead of the loss, we classified our here gain, and then also here gain again. Oops. Okay. Now this is area gain in Gabon. So this will calculate the total area in Gabon that is classified as forest gain, or that means reforestation or afforestation package, however you can call it, or just more plants or more trees growing in that year instead of losing them. Or so that's a positive forest change, right? That's what we wanted. So we need to calculate that. And then so this part of the script is ready to go. Then the next step is to execute that. Fantastic. So as I said, again, Earth Engine is running. This is pretty resource intensive behind the scene when this Earth Engine is actively computing something. again, thousands of computers on Google's side, in Google's data center, are being utilized. So again, thanks to Google for providing this resource for researchers and what have you. Fantastic. So now we have our total area gain in square meters. So you can see that total area gain and total area loss. So if you look at here, the 3 digits here, if you look at this, you can see the 3 digits here. It's here we have 387 million. If you look at here, you have almost 2 billion pixels. That's crazy. So what it means is that the loss is greater than the gain. So that means there is more deforestation in Gabon than afforestation. So that's the implication here. Very, very interesting. And are we done yet? Maybe one more thing. Okay, so we need to display the data. Okay, display the data. All right, so let's just move this here a little bit so that you can see. And so I'll define map center object center object, and yeah, I'll just use Gabon. That's just adjusting the visualization so that it will zoom into the specific study area that we are interested in, right? And then the last thing is to actually add the Gabon data and add layer. And I need to create image. That's an empty image, and then I'll paint Gabon in this case, and then close that, and then I'll define a palette. Gray, and also we'll open that. I think I need to complete that. That should be enough. And the last thing is I'll just create a name for my layer, right? So we can run that. That simply will just zoom in to that study area. So in this example, it's not that we've in the previous lecture we've seen the forest gain and the forest loss data. We've visualized it, so we don't necessarily need to do that here in this lecture. Okay, so that's how you calculate forest area loss, forest area gain for a certain study area. You can change this to your study area. Again, you can change this to your study area or any country that you're interested. It's pretty adaptable. You can adapt this code to your own study region. So that's how you can apply the Hansen tree cover data, global data, and calculate forest loss and gain on the Earth Engine API.